Okay, does anyone remember this? The Definitive Technology SuperCube Trinity. It's supposed to be the 2000 watt subwoofer, but I think that's basically IPP-ILS, instantaneous peak power if lightning strikes. Anyhow, I had it running. It worked great on the bench. I ran it for hours and hours, and I sent it back to my customer. And the customer said he ran it for like 30 minutes, 40 minutes, somewhere in there. And then it started humming. And his quote was actually, begin woofing and popping. He unplugged the signal cable, and it continued until I unplugged the AC cable, he said. So let me try to go ahead and redact some of the customer's information here. And I'll show you the note that he sent me back, which was back in July. Anyhow, sub after plug-in began with a low humming sound. After 40 minutes, it began woofing and popping. I unplugged signal cable, and it continued until I unplugged the AC cable. Round 2. May the force be with you. Well, I think the force is here, and I think I found the problem. I think. So let me show you this schematic that luckily the customer sent back. I do have the schematic, but I made my notes. I can see the capacitor location, and I drew lines. It's all like a big old Dr. Seuss kind of a thing going on here. But what I was getting was on this P32, that's a positive 32 volt power supply, I was getting about 56 to 58 volts on that 50 volt capacitor. And on this one, the N32, kind of hard to see right there, I was only getting about 14 or 15 volts. It should be 32 volts. It has a voltage doubler circuit here. So yeah, that's going to be an issue. Out of this negative 15 volt supply, I had about 1 volt. And it wasn't turning on this transistor right there, so I had basically 0 volts on the positive 15 volt side. I went ahead and replaced all 3 of these large capacitors, C8, 18, and 20, once again, just because this one right there, C20, had been stressed. It went up to almost 60 volts on a 50 volt rated cap. Probably going to be okay. I went ahead and changed it anyhow. So all 3 of these capacitors right here are brand new. And what I think I found is this resistor right there, R16 possibly, 499 ohms. So let me show you that. We'll get it flipped up here. And one of these little capacitors right there, or little resistors right there, is that 499 ohm capacitor. Why do I keep saying capacitor? Holy crap. So let me turn on auto magical focus, and we'll zoom down in there. And as you can see, that resistor right there is yellow, white, white. 499 ohms. Who uses that when they could just put a 500 or a 470 in there? Well, I guess because of the voltage divider circuit that they used here. Yep, there it is. R16, 499, and R21, 5.23K is a voltage divider. Wow, very, very specific values. Anyhow, as you can see, one end of R16 is tied directly to one end of R21. And if it will refocus. So basically, one moment, let me pause this. Well, I thought I had found it, but I might be mistaken. So I have the voltage reduced. Let's power this unit on. I don't have it connected to the high level board. This is the low level board. So checking on C18, which is this capacitor right here. I do have my minus 29 volts, which is perfect. Checking on C20. I do have my positive 30 volts. So let's look at C33. I should have positive 15 volts, and that's going to be If I can read my chicken scratches up here, that should be this capacitor right there. And look at that, I've got 12, if I can stay on it, 12.3 volts. And C16 should be the negative supply, which is this guy right here. And look at that, I've got my 15 volts. So I did go ahead and pull all three of these capacitors out, just in case there was one that was defective, replaced them all. Cleaned a bunch of that stupid yellow conductive glue off the board. I thought I was going to find an open trace, but I did not. But the voltages are correct at this moment. I'm going to go ahead and assemble this thing and put it over in my other room with my dummy load and just let this thing cook basically for days and days at this point. I want to make sure this thing is 100% solid. There is a possibility that one of these capacitors had become damaged. They're all 470s at 50. Kimmit, good high quality caps, manufacture date March of 2020, so they are not that old. But better to be safe than sorry. I do remember one of them did get over 50 volts at one point. Maybe that was the whole problem. And we had that corroded trace, as you saw in, I think it was either part 4 or part 5 of this video. This will be part 6, obviously. So let me throw this thing back together and see if it wants to power on when the high level board is connected. One moment. Okay, everything is connected back together. The low level board and the high level board are mated together through that one plug, and then the AC cord that does supply power over to the power amplifier, or what they call the high level board. So let's put you in manual focus and we'll hit the power button. I did see capacitors charged. That is good. I do not have an input connected to it at this moment. I should see that red power LED power up after a few seconds if everything is successful. So I'll give it a moment and see if it's going to power up that red LED. I'm probably going to cut away and come back. One moment. And we do not have power up. It's been more than long enough. So I'm going to remove AC power, flip this board over, and measure the voltage on these two capacitors right there. One moment. Okay, here we go. AC power has been applied. I'm going to put this in the 60 volt range. And I'd like to see about minus 30 volts, and I do. And 30 volts on that one too. That's absolutely perfect. Why is the unit not powering on? Interesting. Let's go ahead and check the voltages out of the regulators. So C16 and C33. Let me get my page oriented correctly. So I have minus 14.9 volts on C16. And then I do believe this is C33. And I've got 12 volts, 13 volts on that one. That should be perfectly fine. I do have the voltage slightly reduced. I'm only running about 110 volts right now. Let's get it up to 125 and see if that might have been the whole problem. I do believe this unit should power on with no input, but I might be mistaken. I have been wrong before. The main thing I want to make sure is that I'm not over juicing this capacitor, 34 volts, or this capacitor, 33 volts. That's perfectly fine. Yes, they're perfectly fine. Well, let me put an audio source into it and see if it wants to power up at this point. Okay, here we go. Audio source is connected. I do have the input level all the way at 0. Power on. And I'm watching the current. It's very, very low right now. Just a couple of watts input. Probably these two transformers. It has not turned on the 4 output FETs, which will have a certain amount of bias. I think it pulls it up to about 20 or 25 watts once it does successfully power on. And hopefully that is all that's going on with it. Oh, it did successfully power on. I heard the little chirp, and we're pulling about right at 25 watts. And there is audio. Probably an average audio of about 75 watts RMS right now. And that's working perfectly. I'm just going to let it sit here and cook for the next few hours. And then I'm going to move it into my other spare room, which is basically my test room. I'll move the dummy load over there and make sure everything is good. Well, there is the SuperCube Trinity after the 3 capacitor replacement right there. It's been working perfectly. It is currently April 23rd, and I started this thing on April 5th when I started making these videos, and I've been pushing this thing hard. I'll show some infrared camera images in just a moment. Here you go. So the Definitive Technology SuperCube Trinity has been running for days and days and days, and I don't see any issues with this unit. And I'm pushing this thing pretty doggone hard, as you can tell from the temperature of the dummy load in here. It is 265 degrees, and it has been running absolutely perfectly. So I think at this point, I'm going to get this thing boxed up and ready to ship back to my customer, which I don't even remember where this customer lived at. But anyhow, it, I believe, is complete. And as you can tell, I'm definitely pushing this thing pretty good. 200 degrees with those big old resistors. And of course the dummy load down there. Just the top of the dummy load is 108 degrees, not to mention the inside. Let's see what it is right now. Yeah, 260 degrees basically, 260, yeah. So we definitely got some load going into the dummy load. All right, going to ship this thing back, and hopefully everything will be good for years and years and years to come. Thanks for watching. Everyone have a great day. Bye-bye.